This video covers D3 and HTML forms. The structure of this video is as follows. HTML form basics. Listening for HTML form events. Form event triggers D3 transitions and the summary. Alright, let's get started. HTML form basics. You are probably familiar with this famous web form. This is Google's search web form. Type anything you want and Google will conduct a search of web documents for you. Its simplicity and functionality have been widely covered. It consists of a text field input and two buttons, a Google search button and an I'm feeling lucky button. If you're watching this video, chances are that you are an expert at using/filling out forms and may have even created your own forms in the past. Because of this, we'll keep the basics brief. For the purpose of this video, we'll cover the basic HTML form and radio buttons. An HTML form is created using the form tag. There is an opening and closing tag. And just like any HTML tag, we can add attribute value pairs to further define the form. Some common attributes for a form are the ID, action, and method. The ID specifies a unique identifier for the particular form. The action attribute value pair is used if you are submitting data. It tells the form where to submit/send the data so that it can be processed. The method attribute tells the data how to travel. Two request methods you may be familiar with are get and post. The get method requests data from a specified resource. The post method submits data to be processed to a specified resource. This is why almost all web forms you encounter will have the attribute value pair of method equals post. Inside of the form, we can have various form elements. You can see the new ones added by HTML5. We can have as many elements as we want in any form and can mix and match as we please. Last but not least, almost all forms will have an input element with the attribute type and value of submit. Instead of rendering an input element, this HTML element will render a button that, when clicked, submits the form to whichever action was specified by the method specified. That's pretty much the basics of the forms. The bigger picture of a form is that it allows for further interaction between a user and the web page. It is within this big picture thinking of a form that we will use it with D3. More specifically, we will focus on not submitting information to a server, but the actual checking of a radio button. The radio button has a change event that we can listen to, so it's easy to get started this way. Checkboxes and other form input types need a bit more hand-holding with JavaScript, so we'll leave those for later. Radio buttons are a good starting point because of the way that they make it easy for us to capture both their change as well as their value. When a user clicks on a radio button, it becomes selected, and all other radio buttons with an equal name become unselected. Let's take a look at what we are going to be building in this video. On the screen you can see two radio buttons, one with the label width and one with the label height. When I click on the width radio button, you can see the width of each rectangle expand and then contract. When I click on the height radio button, you can see the height of each rectangle expand and then contract. This can be very useful when toggling between datasets, showing different features of one dataset, or showing two different types of visualizations of the same dataset. Notice that in this form we are not submitting anything. We are just using the change event of the HTML form radio buttons to cause D3 to transition either the width or height of each rectangle element. Let's now dive into the code to see how we are going to build this. Listening for HTML form events. Let's start with the HTML form that we are going to use. There are two labels for the form, one for the width and one for the height. There are two radio input buttons. These radio input buttons are created with the HTML tag input. We specify the type attribute to be equal to radio. Each button has attributes of type, name, and value. The type is what defines the buttons as radio buttons. The name is what is used to link the two buttons together. The value is the value of the radio button. Additionally, the labels provide a text that we can read next to the radio buttons. If we look at the two radio buttons, we can see their similarities and differences clearly. The similarity that we are going to focus on is the fact that both use the same tag of input. D3 gives us the ability to create a selection based on HTML tags, so we will be using the input tag to create a selection of these two HTML form elements. Note, we can use input because the example web page we are going to be working with only has two input elements. If we were working as part of a larger project where the web page might have more than two input elements, we would use a class attribute for each input relevant to the visualization in order to create a D3 selection of the correct elements. Similar to when we select rectangles, circles, or any other type of DOM element, we can create a selection using the D3 select all functionality. Just like with any other type of selections, we can add any attribute value pair that we want to every element in this selection. This is where D3 really shines through for me. Not only are we able to affect SVG elements, we can also affect HTML elements in the same code. Once we have this selection, we can add an event listener to each element in this selection. Event listeners on HTML elements work exactly the same way as event listeners on SVG elements. This is because the event listeners are DOM event listeners, and HTML and SVG elements are both DOM elements. The radio button input element event that we can listen to is change. When the radio button is clicked, it will emit a change event. When we use D3 to listen for the change event, we are able to specify what JavaScript function should be run. Because we use D3, the D variable, I variable, and this variable are available to us for use inside of the function. We can either use an anonymous function as shown, or we can define a named function elsewhere and put the name of the function as the second argument of the D3 on event listener. This will be the first example we run in the JavaScript console. A few things to note. First, the HTML form will be hard-coded into the HTML document, so it will be something that we add/edit in the text editor. Second, we are using this dot value in the function even though we aren't passing it in. Without getting too deep into JavaScript function scope, closures, and nested functions, know that if a variable is available in a function, then it will be available in a function inside of that function. This is how we can use the this variable without actually passing it in. Third, this dot value will give us the value of the radio button that was clicked. In our specific case, this will either be the string width or the string height. Let's run the example in the JavaScript console. First, we add in the HTML form into the web page document using a text editor. Note that we put the label, radio input, and text in one line for ease of using the Chrome developer tools. Otherwise, the labels interpret the empty spaces before and after the text as actual spaces and jumble up the code. We save this file down and open up the web browser. This web page has the D3.js library imported from the D3.js.org website. Let's take a look at the Chrome developer tools. We can see the form, the two labels, and the two input elements. First, we define the input element selection. We can see that the selection looks like any other D3 selection. We can also see that there are two input elements in the selection. Second, we define the input change named function, which will alert us when a radio button is selected. Lastly, we define an event listener for every element in the input elements selection. You can see that as I click on either one of the input elements, that an alert pops up telling us that the event listener has been triggered. This shows us that we can use D3 to listen to HTML form events and specify what functionality we want to happen when the event is triggered. We will use this in the next section to trigger SVG element transitions whenever one of the input elements is selected. Form event triggers D3 transitions. Now that we have an HTML form that has inputs that have D3 event listeners attached to them, let's work on the SVG part. Previously, we have just been appending the SVG element to the body element. Once we start doing more complicated visualizations, it's helpful to separate different parts so that it's clear what is going on where. To this end, we will add an HTML div tag with an ID of visualization. Inside this HTML div tag is where we will add the SVG container and construct the SVG rectangle elements. This code selects the HTML div and appends an SVG element to it as the last child element. Then we define the width and height of the SVG viewport. This code defines 3 different rectangles. Each data object has an X, Y, height, and width. Then we use the D3 pattern to bound the rect data array of JavaScript object literals to SVG rectangle elements. Once the data is bound to the SVG rectangle elements, we use the bound data to create the attributes necessary for the rectangles to be displayed. Note that we add an ID attribute to the rectangle. Though it's not necessary for this example, it's good to always name the elements you create, as it helps with debugging the code. Next, we define a function that, when evaluated, triggers a transition of the rectangle's width. We will call this function changeWidth. It uses the rectangle's selection and applies 2 transitions to each element of the selection. First, it increases the width of the rectangle to 300 units over a span of 3 seconds. Then, once the first transition is done, it decreases the width of the rectangle back to 50 units over a span of 3 seconds. Next, we define a function that, when evaluated, triggers a transition of the rectangle's height. We will call this function changeHeight. It uses the rectangle's selection and applies 2 transitions to each element of the selection. First, it increases the height of the rectangle to 300 units over a span of 3 seconds. Then, once the first transition is done, it decreases the height of the rectangle back to 50 units over a span of 3 seconds. We now have 2 functions that will cause a transformation of the SVG rectangles. While we could have written these functions as anonymous functions within the event listener, this way of writing functions is easier to follow and debug. Going back to our event listener and input change function, we have to do 2 things in order to get this to work correctly. 1, we have to be able to differentiate between the width radio button being clicked and the height radio button being clicked. 2, once we know which button was clicked, we have to call the right function. We can use the this.value to get the value of the radio button that was clicked. Once we have the value, this solves issue number 1, how to differentiate between the 2 radio buttons that were clicked. Then we can use an if-else conditional expression to cause either the changeWidth or changeHeight functions to be evaluated. This solves issue 2. Now, when the event listener receives a change event, it will figure out what the value of the input element is and then evaluate one of the 2 functions that causes a D3 transformation. Lastly, we always have to remember to bind the event listener to the elements. Because we are working in the JavaScript console, this will always be the last thing we do. If you are looking at someone else's code, oftentimes this will come before the definitions of the JavaScript functions. This is due to JavaScript function hoisting, which is something for another time and place. Let's concentrate on the example we are creating. Let's run the example in the JavaScript console. First, we add in the HTML div to the web page document that contains our form using a text editor. Note that we put it after the form to ensure that the form element is above the SVG element. We save this file down and open up the web browser. This web page has the D3.js library imported from the D3.js.org website. Let's take a look at the Chrome developer tools. We can see the form, the 2 labels, the 2 input elements, and the visualization div. Before we start building the visualization, we create a D3 selection of the HTML form, radio button, input elements. This selection will be used when we want to attach event listeners to the input elements. Now, to create the visualization, let's first create the SVG viewport in the HTML div with the ID of visualization. Next, let's define the rectangle data that we will be using. This data is an array of JavaScript object literals. Next, using the D3 pattern, we bind the data to SVG rectangle elements. You can see the rectangle elements in the Chrome Developer Tools Elements section. Finally, we define the rectangle attributes so that they will appear on the screen. And with that, we now have the rectangles that will experience transformations each time the HTML form radio buttons are clicked. Next, we define the width transformation function called changeWidth. Recall that this function expands the width and then contracts the width of every rectangle in the rects selection. Now, we defined the height transformation function called changeHeight. Recall that this function expands the height and then contracts the height of every rectangle in the rect selection. Let's test the changeWidth function. You can see that it works correctly. Each rectangle has its width go from 50 to 300 and then back down to 50. One question that may have come up is why do all of the rectangle's right edges seemingly end up in the same place? That is, if the rectangles are at a slant, then we would expect that when their widths increase by the same amount, that the right edges would still be at a slant. The issue is that the rectangles go beyond the 300 by 300 SVG container, so the extra parts of the rectangles disappear. This is very helpful to encounter and think about when you are making data visualizations with D3. Remember, if it's out of the SVG container dimensions, it will not be visible on your screen. Let's test the changeHeight function. You can see that it works correctly. Each rectangle has its height go from 50 to 300 and then back down to 50. Similarly to the changeWidth function, the rectangle's bottom edges seemingly all end up at the same place. This is the same issue as with the width. The SVG viewport is 300 by 300, so a good portion of the rectangle's new height is hidden away from us. So remember, if it's out of the SVG container dimensions, it will not be visible on your screen. Alright, so both transformation functions work correctly. Next, we define the input change function, which is what will drive the functionality. Note that this function is difficult to test from the JavaScript console command line because we need a this object to get the value from in order to use the conditional expression. Finally, we attach an event listener to each element in the input elements selection. You can see on the screen that we are able to replicate the example at the beginning of this video. The full description of what is happening is the following. Each HTML form input element is now listening to the change event. When it receives this event, it will call the input change function. The input change function will then figure out the value of the button that was pressed. Then, using this value, it calls either the changeWidth function or the changeHeight function. If the changeWidth function is called, it will increase and then decrease the width of all the rectangles. If the changeHeight function is called, it will increase and decrease the height of all the rectangles. Somewhat complicated, correct? This is why we use named functions rather than anonymous functions. Though it is entirely possible to write all of this functionality as a series of nested anonymous functions, it is better to use named functions. And with that, we have covered how we can use the HTML form basics to build HTML forms whose input elements have event listeners attached to them that when triggered cause D3 transitions on SVG elements. The summary. This video covered HTML form basics, listening for HTML form events, form event triggers D3 transitions, and the summary.